are live. Hi, everyone, and welcome back to Dev Show. My name is Sherry List, and I am super excited to be your host today, together with a good colleague of mine, Rasmus Jack. Hi, Rasmus. How are you doing today? And in a scale of 1 to 10, how excited are you to be on Dev Show today?
I am feeling fantastic, thanks, Jerry. And on that scale, must place myself on a 15, I guess. It's been a long summer, and now we're back. But who doesn't have 5 months summer vacation, right? How are you, Jerry? And where are you placing yourself on the same scale?
Yes, same. This side, if it's not above 15, it's about the same. So I'm super excited, and it is great to be here. I cannot get over it, but we need to continue because we have a super awesome agenda for today, fantastic speaker, and a great topic to cover. But before we start, before I handing over to Rasmus to talk about the agenda and our speaker, thank you, Rasmus. Yes, I want you all to be aware of our code of conduct, which the link is below. It is pretty simple. All we want from you is to be mindful and respectful of each other once you are interacting with each other in the chat. We really want to see the interaction there. We really want you to share your feedback, post your question to each other, even jump in and answer the question that you want to. But please have the code of conduct in mind. We never enforced it before, and we hope we never do it, but we really want you to be aware of that. And also, just like any other dev show before, we have a feedback form. We are going to ask you to fill it out. One person that will fill out the feedback form will get a swag box from our side. And also, everyone is going to get an Azure Heroes badge with the name of our speaker, the title, and our name in it as well. So, yeah, we need to include ourselves as well. So, back to you, Rasmus. What do we have on the agenda today?
Yeah, thanks, Jerry. And look forward to the badger, learner badge with our name and Mark's name on. So today we're gonna learn about how to prevent building a serverless monolith. So a lot of us is building serverless applications, and as Mark says, this is so easy that it easily gets complex. But in this session, he's gonna teach us about the application architecture, bounded context, scalability, resilience, and monitoring of serverless applications. So that's gonna be exciting. So should we get Mark on stage?
Hi, Mark.
Hello.
Welcome to Dev Show. Welcome back.
Yeah, good to be here again. Definitely, it's been a while.
Yeah, glad to have you back. I just noticed that the last time you were here, it was November, but last year. So
exactly. Wow. Exactly.
So
I'll have maybe kind of a subscription would be nice, like so a yearly Dev Show subscription for me. So I come back every year. I would like that.
Yeah, we can work on it definitely. But of course, we want to have you more often than
okay.
Yeah,
no problem.
Maybe a quarterly instead.
Sure. I've got enough topic to talk about, so no problem at all.
Amazing.
Great. I guess since last time that we have you here, you had a job change. Maybe we can tell us about your new job.
Yeah, exactly. Just a couple of weeks ago, I joined Ably. It's a UK-based company, and they're building the definitive real-time infrastructure for the web. So if you're involved with real-time messaging, PubSub, messaging also for the last mile to all kinds of end-user devices, then they have a great product for that. I'm still very much into the Azure and .NET community, so I'll be building lots of content and demos with Ably in combination with .NET and Azure.
Fantastic, great. And
sounds really cool.
Yeah.
So I hope you still have time to make pixelated animations. I remember we spoke about that last time you were on the show. So you need to tell us about the favorite one you made since the last time we spoke.
Oof, yeah, that work never stops. So I can still be commissioned for these pixel art avatars. I still do that, but also still make some just for my own. When I left my previous company, I announced that with some pixel art animation. When I joined Ably, I made a pixel art animation of that as well. So that was almost 2 minutes long, and really, I think almost 200 frames. So that was really lots and lots of hours of work. But I really like to do it. So I'm also still learning it, I think. So there's definitely room for improvement there. So I hope the coming years you'll see also much more pixel art from me as well.
That's great. And for those of you who haven't seen that animation, I'm posting it in the chat. So
and maybe soon we'll see a full movie in the theater with Marc Duiker.
Oh,
That'd be
Yeah.
amazing.
Yeah, exactly. Yeah, it will take a couple of years, but sure. Yeah.
But we'll look forward to that.
Yeah.
But great to have you on the show again, Marc. And I think let's jump into today's topic, and we'll just hand over the stage to you and bring your screen on stage. Looking forward to hear what you have to share.
Great.
Take it away.
Let's go. All right, so we're going to talk about how to prevent building a serverless monolith, or maybe not. We'll see. So although this monolith here looks a bit sad, this is not a sad presentation. So there will also be happy monoliths, I promise you. Well, I already told you, my name is Marc Duiker, developer advocate at Ably. I'm also a Microsoft MVP for the last 3 years. I've done a lot with serverless architectures and event-driven architectures. I've also started Azure Functions University. It's a free and open source curriculum on GitHub where you can learn all about Azure Functions. So let's talk a bit about monoliths, specifically serverless monoliths, what impact it has on agility when you're working with them for a while, what complexity efforts and impacts it has to have these monoliths and to work with them. And if you decide to break them up, I will give you some strategies how to break them up. So let's first talk about serverless monoliths. And here's a happy monolith. So and not all monoliths are very sad or evil. Definitely not. So as Rasmus mentioned, creating serverless apps on Azure is really easy. And I don't usually use the term easy because something that might be easy for me might not be easy for you. But if you've been exposed to a bit of Azure Functions, then you probably recognize that, yeah, it is actually quite easy once you have one to add more functionality to it, for instance. And that is both a blessing and a curse. What's important to realize is that the unit of deployment, so your Azure resource, that is a function app. And that function app can contain multiple functions. So the example here of function A, B, and C, all of these functions are individually triggerable. So the A could be an HTTP trigger, and B could be a queue trigger, and C could be a service bus trigger. And there's no limit on how many functions you can actually put inside your function app. So over time, you start with a small function app with just maybe 2 or 3 Azure functions. But then over time, you add more functionality and more functionality. So this function app grows and grows and grows. So there's more responsibility inside your function app. And at a certain moment, you can ask yourself, okay, did I now build a serverless monolith? And if so, what should I do about it? So it's first important to realize, what do we mean with monolith? So I looked the definition up on the internet, and there are a lot of definitions out there, unfortunately, but the one I chose was this one from Wikipedia. So in software engineering, a monolithic application describes a software application that is designed without modularity. So the key is the without modularity part. So you can think of it as a big black box. It can't be taken apart into smaller pieces. It's just that big thing. You deploy it as a whole, and you cannot change anything about that. So when people hear monolith, it usually has a bit of a bad vibe to it. And then that's because when you look at traditional architecture, you have this big monolithic app server that contains all of your presentation code and your business logic code and your data access code for all kinds of different functionalities that you've programmed. And that communicates with your database server. And this used to be quite common. And a lot of places, they're still running this. And it's not a bad thing per se. Right, so hey, you might be very happy with your big application server. So maybe it doesn't take much time to do maintenance on it. And maybe it's very easy to keep adding stuff to it. So if you're happy with it, fine. But today's architectures are usually quite different. So usually the applications are quite smaller, and we also have different services in the cloud to make use of. So what we usually have, we have a function app where a request comes in, maybe some validation gets done, and then a message is put on a queue, and then a different function app can pick that up from a queue, does some more processing, and store something in a database. And this is a very simplistic flow just for one functionality, but you can imagine that in a bigger service architecture, you might have dozens of these diagrams. So in this new serverless architecture, the modularity is interwoven in the architecture itself, because the architecture is making use of very small applications. So the function apps are relatively small compared to the traditional app services. And all of the other services, such as queues and databases, are usually also quite small. So the modularity here is not inside the function app itself, but the modularity is due to that you're using a lot of different cloud components. So is it really necessary that your function app, should it be modular? So is it a bad thing that your function app is a monolith? So I think not. I think it should be fine. I think it might even be desirable if your function app is a monolith. Because in the end, it should be a small thing. It should only have one responsibility. And if you want to exchange something or change something in your serverless architecture, it should be relatively easy to replace one function app with another implementation, or replace one of the other components. So I think actually every function app should probably be a monolith, because why should something very small even be modular? And I'm not saying you shouldn't use interfaces in your function app, because I still believe that things should be unit testable. And so at a certain level, especially at the code level, it should still be modular, because you want to have nice testable stuff. But otherwise, I think it's fine that your function app can actually be a monolith. So monolith does not mean bad, definitely not. What is important, however, is to realize if your monolith slows you down. So that can be quite tricky if that's the case. So let's have a look at agility now. So all companies are want to do agile these days, right? They want to be quick when there's a change. So that also means that developers usually work in sprints. You have your Scrum team, you have developers and testers, cross-functional teams, and all of the stuff that you do still takes time, right? You do adding features and testing, and then looking for bugs and fixing bugs, documentation and deploying to production. It all takes time. If you're starting out on a completely new project, these things take time. But if you're working on a project that's already been running for a couple of years, then a lot of these things take more time than it took at the beginning, right? Just simply because your application has grown over time. So if you find a bug in a small, or if you need to diagnose a bug in a small application, you only have to look at a small piece of source code. But if you have to diagnose a bug in a very big application, where do you start then? So things will take more time the bigger the application is. And that's definitely part of a problem then. So then, your whole team is then not so agile anymore, because you are having quite a heavyweight monolith, which is not so maintainable anymore. So usually over time, when your application size is growing, the agility of your team goes down. So that's a bad thing, and you want to monitor this, right? You want to know when your agility goes down, because then you can act on it, which is also very important. But how do you monitor agility? So I think that's a very, very tricky one. Agile and Scrum, you can use story points for that. I think it's been used with mixed results. So I don't think it's really that tangible. So I would prefer to use another metric instead of agility and story points. And one of the more well-defined metrics come from incident management theories, and that's called mean time to recover. So there's a couple of links in this slide, so I definitely recommend you to look at all of them to get more information, because there are many other metrics mentioned in incident management. But what mean time to recover means is you have an incident and that results in an outage, so something isn't available for your end users, and how long does it take for the entire system to become up and running and completely operational again. So how do you calculate that? You divide the downtime, let's say in a month, you divide it by the number of incidents you have in a month. So as an example, if you have in a month 12 hours of downtime and you had 6 incidents, your mean time to recovery is like 2 hours. And that number, although it is an absolute number, it doesn't say anything yet, right? So because for one business, 2 hours of downtime, maybe no customers have visited your website and nobody notices. Fine, no problem. But maybe you've lost like 1 billion euros right now. So it is a big deal. So if this is important, it's up to the business. But I think it is important to keep this metric in mind and to monitor this, because it's something that is tangible, that can be measured, and can also be alerted on that. So if you find that your mean time to recovery increases over time, that means something is wrong. That doesn't mean something is wrong in your application per se, because it can also be the process. So maybe your process has changed and you now require a 4-step procedure to deploy something to production. Okay, so then you need to fix that. But it is very likely that it could be then related to your growing technical depth, maybe in your serverless application. So you don't want this. If it's not increasing, if it's staying the same, and you are okay with having a downtime of several hours for each outage, that's fine. But ideally, you even want to go down further and further. So we're now touching a bit on the technical depth of an application, and that we're now moving into the realm of complexity. So I looked up what does programming complexity actually mean, and there are actually different types of complexity when it comes to programming. There's essential programming, and that's caused by the nature of the business problem, and that can't easily be reduced. An example of that is the traveling salesman problem. Maybe you've heard of it. If you have X points on the map and you have to calculate what is the shortest path between all of those points. And that's an inherently difficult problem, and you can't easily solve that or make it simpler. The other complexity is called accidental complexity, and that's caused by the decisions we make, that the development team makes. So we decide on a language we use, we decide on frameworks, we decide on packages, we decide on a certain coding style. All of these things lead to some kind of accidental complexity, but we can tackle that. It still means we have to invest some time in it to improve it, but at least it's possible. So let's focus on that. So let's say we have a serverless application with 4 major parts of functionality, and we have identified that it's become too complex, it's too hard to maintain it, and we've decided to actually take it all apart and move from one big application to 4 smaller applications. So that's definitely possible, right? And we have this situation then, but you really have to be careful how you do it, because if you don't do it the right way, you can end up with this, which is actually a distributed monolith. And I think if you have to choose between a monolith and distributed monolith and completely distributed, then I would suggest just either stay with the monolith or go completely distributed, but don't be in this situation. Because this means you have individually deployable units, but they still very heavily depend on one another. And what that could mean is that if you make some kind of code change in A, you still need to make some code change in B or C or D. And so there could be a code dependency on it. It could also be a dependency in your CI/CD pipeline. So maybe you have only one CI/CD pipeline that deploys all of these 4 applications, while in fact you should have 4 individual pipelines to deploy all of these applications. So there could be different reasons why you could end up with a distributed monolith, but I don't think you want to be there. What's also important to realize is that complexity does not evaporate. So that means if we are moving our code from 1 application to 4 applications, it doesn't mean that the complexity is then completely gone. No, it means that the complexity is now distributed, or it's moved to 4 smaller parts. So each part is more than contained, and it's probably more maintainable if you look at each function app individually. But there's also now more overhead, because instead of deploying 1 function app, you now have to deploy 4 function apps. So there's more CI/CD involved there. And so especially if there are some dependencies there, maybe it's not possible to deploy all of them individually, and maybe so you're more in the distributed monolith situation, then it becomes even more complex. So even though you are breaking up something big into smaller parts, it doesn't mean you have completely removed the complexity. You have probably reduced it in one part, but you have increased it probably in another part. But maybe you've moved it to a place that's not your responsibility, which is fine. So then it's not on your plate, but it's never always gone. So that's important to realize. So one of the things for reducing or moving complexity would be moving code to a new app. Like the example we saw, we go from 1 app to 4 apps. So that's an obvious route to go. So that's fine, but then it's still, I imagine that function app was part of your team, but now you have 4 function apps, which are still probably your team's responsibility, right? So all of the complexity, you still own all of the complexity. Another way to look at reducing complexity is to look into third-party packages. And so maybe you have code written in your application, and that code can be replaced by using third-party packages. One of the examples is one I see frequently is that people write their own validation code. So they do some kind of input validation on some kind of model, and they write it all by hand. But there are packages like Fluent Validation, for instance, for .NET, and they do a really good job of you can write your validations, you can unit test your validations. That works really well. Another example might be you want to simulate some fake data. So for instance, you can use Bogus for that. So that has a very nice, realistic implementations of generating fake data. So be very mindful of these examples, and that can be hard, right? Because it's very hard to know what is out there. But I think it's definitely useful to look around the internet and look around on GitHub to see what kind of packages are out there, which can reduce your own code base. But then you move some complexity by using one of the other packages which are out there. Again, the complexity is not completely gone, because you're then in charge to not maintaining that package, of course, but you have to make sure that you continuously upgrade that package to make sure you don't have any security incidents in case something is found in one of those packages. So again, it's not completely removing the complexity, but the complexity will be less. Another very big step might be to use a completely new third-party service. One of the better examples I have there is, for instance, email. So I hope nobody is dealing with their own email server these days anymore, because there are lots of services for email, like Twilio and SendGrid and those kind of things. So yeah, have a good look at your code base, and yeah, really, it should really be as lean as possible, right? So the less code there's in there, that's usually the better. So let's now have a look at some breakup strategies. If you decide that your application is too big and you want to do something about it, you want to break it down into smaller parts. So how do you do that? So I've got 3 aspects where you can which you can use to break your application down. One is to look at the bounded context. One is to look at resilience, and one is to do with scalability. So if we start with bounded context, if you haven't heard of this term, it comes from domain-driven design. And in domain-driven design, you usually map out your domain that you want to apply your solution in. And so you have descriptions of your object model, you have description of events and commands and stuff like that. But that whole domain description is usually too big to fit in one application. And that is mostly because we don't want to build an entire black box monolith anymore that contains the whole domain. We usually want more smaller, manageable pieces, which can then be handled by different teams. So each team would be responsible for a part of that domain. So these parts of these domains are then named a bounded context. So a bounded context is a part of the domain, but it's the technical implementation of that part of the domain. So usually you have a bounded context that is a small web application or a microservice or a function app. An example would be an e-commerce platform. So that's the domain. And examples of bounded contexts are then a microservice for the product catalog that contains descriptions and images, an inventory management system that contains the stock, and a service that contains the billing information, and a service that manages your shopping cart. So within a bounded context, there's a ubiquitous language, or there should be a ubiquitous language. So if you haven't heard of this, ubiquitous language identifies the terms and concepts within a bounded context that are unambiguous and agreed upon by all stakeholders. So again, if you haven't heard of it, there's some links there which I recommend you to follow. What's important to realize that language is really very important, and domain-driven design very much highlights that and really demands that within a bounded context, so a specific implementation of your domain, you all agree on the terms you use. Everybody understands what they mean, and it only means one thing. So that's very important. So I've got an example of 2 different contexts, but the same domain model. So on the left-hand side, we have an account in a banking context, and on the right-hand side, we have a domain model named account in an e-commerce context. So although it's the same word, they both have 2 different meanings. So an account in a banking context has to do with an account number, it has to do with money, with debit or credit. When we are talking about an account in an e-commerce context, it usually deals about the login, a username, password, some personal information, shipping address, and so on. So it's fine to have the same name of a model in 2 different bounded contexts. So that's totally fine. But within one bounded context, then every domain model should have only one meaning, and everyone should agree on that. And so how is this all relevant for deciding on if my serverless application is too big, and how should I decide to speed it up? Well, I believe your function app should only deal with one bounded context. So it should only deal with one specific technical implementation of your domain, and not more of it. And how can you identify that? Well, you should look at the language that is used in your function app. So if it contains, for instance, several domain models which maybe look alike but actually mean something completely different, or maybe something slightly different even, then it's a sign that you probably have a multiple bounded context inside your function app, and that should probably not be the case. Another aspect to make the decision how to split up or break up your application is to look at resilience. So let's say we have our big serverless monolith, and one functionality breaks down, and it breaks down in such a way that it brings down the entire application. So that's definitely something we don't want, right? Because requests are coming in for A and B and C and D, but all requests to B make sure that the whole app is down. So all of these other functionalities are not available anymore. And again, if you're serving like millions of customers, or a lot of money is involved, this is a very bad scenario to have, right? Because maybe this time it's B that's failing, but next time it's C is failing, and that causes all of its neighboring functions to fail as well. So in this case, it's definitely recommended to take out that functionality and put it in its own function app, and put it in its own deployable unit, its own Azure resource, because in case it does fail, only that part fails, and the rest can then simply move on. So if we look at the simplistic schema again that we saw before, in this case, we have two function apps separated by a queue, and then we end up in a database. If the second function app fails, but all requests are coming in the first function app here, then this first function app happily continues, right? So if these are orders that are coming in, and they are being partially processed, they are put in a queue, but then it stops, right? But as soon as this second function app fails, I hope that the team is very aware of that and will start fixing it right away. So hopefully within minutes or maybe hours, this function app is up and running again. And as soon as this is up and running again, it will happily consume all of the messages from this queue, and this queue will probably be immensely big by then, but that's okay. And then it will process, will continue and persist everything in the database. So yeah, always try to identify when it's really, let's say, more critical things, to really have these things individually deployable. So if one thing fails, it doesn't bring down the entire system. So the final one is to look at scalability. So again, we have this function app with 4 different functionalities in there, but 2 of these functionalities cause a big fan out. So A and B cause a fan out, and what I mean with fan out, maybe one request comes in, but that results in hundreds or thousands or even millions of other requests. So that means that a lot of more instances of this function app are being created. So lots of virtual machines are being used, and if A and B are causing let's say the same level of scale out and require then the same level of scale, they might then compete on the same resource, because they are all in this same function app, which is on a certain tier. So this might cause problems. So there are 2 ways out of this. One way could be to just break out the functionality that also causes the big fan out, right? So in this case, we have one application which can do a fan out here, A, and the other one is in a separate resource, and it has its own dedicated CPU and memory, and it can use it to its fullest. So these 2 are not competed anymore. And C and D, they don't really matter, because they don't cause a fan out and they don't cause any scaling issues. So this is a logical approach. If the load is really high, then this would be a good one. Another option, which is I think as valuable, is to actually still keep these 2 higher fan out functions together, and then separate them from the lower fan out, but actually put them in a higher tier or higher SKU. So maybe C and D you keep in the standard consumption model, but A and B you can put in a premium tier, because then you have more control over the size of the machines you use. So you can have a bit more control over the CPU and the memory that is used. So again, I put some links here, and these links go straight to the Azure Function docs that describes the different tiers. So finally, I've just this slide, and I want you to ask yourself these questions before you make any changes to your function app. So do I really need to write this? That should be the first question you should ask yourself, because maybe there is a completely servers ready to be used, so you don't have to write code at all. Maybe some glue codes or integration codes, but no functionality to write. Or you can use some kind of third-party package. And if not, then you can still decide if you can write it. Then if you need to write it or add it, is it a good fit with the rest of the application? So that has to do with the bounded context. So is the thing that you're going to add, is that new feature, does it fit in the same technical boundary, the bounded context of the domain, or is it something separate? And if it is something separate, then it should move to its own function app. Is it also a good fit scaling-wise? So will this new functionality, will this require a big fan out? Would it then be better off if you put it in a separate function app so it can have the full scaling capacity there? And the final one, what was the impact regarding resilience or complexity of the app, right? So what if you add this new feature, but what if that fails and it brings the rest down? Is that likely? How big is the problem? Or what if the other stuff fails? Can it bring your stuff down then? And what kind of risk are you willing to accept there? And that's not a decision that is just for the developer. That is more like a business decision as well. And also look at the complexity. So yeah, we didn't talk really about the complexity metrics, but there's always like some code metrics you can have a look, right? Like cyclomatic complexity and things like that. Lines of code, for instance, could also be a very, very basic one. But really look for, is this not growing too big? And what about maintainability? Is that still doable? Right, so if you have more questions, well, you know where to find me. You can contact me on Twitter. On Twitter, there's also this AZFunk Updates account, which posts tweets when there's new releases related to Azure Functions on GitHub. And the bottom link is the link to my YouTube channel. So thanks.
Yeah, thank you very much for the talk. I guess again, a call out to all of you out there that if you have a question, you still have Marc here. You can ask all of your questions there. I know there was a question there that Cosmos would like to ask.
Yeah, so Baha is asking, how does Marc maintain his beard? It's awesome. So I'm going to ask the same question, but now that one of in the audience did it, then I didn't have to do it.
Yeah. No, I'm definitely giving it a good treatment every day with some beard oil and stuff, and go for a regular barbershop visit. So yeah, it's in the beginning, before I had the beard, I thought, oh, maybe it's just easy if I had a beard, so it doesn't require that much attention. But no, it actually costs more time to have a beard. So yeah.
That's amazing. Thanks for that.
Do you want to go for the next question, Rasmus, as well?
I can do that. So Iqbal is asking, saying, hi, Marc. I can just put it on the screen as well here. So thanks for the session. Bottom line, one bounded context is in one function app. I'm getting the concept full to prevent building serverless monolith.
Yeah, that's exactly what I'm saying. Yeah, right. Yeah, so the bounded context is a technical implementation of a part of the domain. So indeed, I'm definitely suggesting use one function app then as the boundary as your bounded context. Yeah, and the bounded context, there's not a given size for it, right? So you can make the bounded context as big or as small as you want, right? As long as it's manageable for the team that's responsible for it. So yeah, it's fine to have lots of small bounded contexts, which are then your function apps. So it's totally up to, let's say, the development team to decide how big the bounded context is and how well that fits in your application.
Great. Thanks for that.
So, are there any more questions? Maybe we can actually go to the answer slide. But still, meanwhile, if there are any more questions, you can just type it there. We will just paste it for Marc. So in the beginning, I promise you all that you all are going to get an Azure Heroes Learner Badge with Marc's name, our name, and also the session name in the NFT. So to get it, just scan this QR code. And if you never had an Azure Heroes before, you have to, after you scan this QR code, you need to download an app which is built for our partner Engine, which is your digital wallet to keep these cute NFTs out there. And for those of you that you had this Azure Heroes before, if you happen to have at least 15 of them so far, because it's been quite a long time that we're distributing these badges, that you can get it in the different session by doing different activities. So fill out this form. You will get a very special package from the badger to you. So fill out this form. We will get back to you to actually give your special swag box answer.
I'm just saying, if it contains chocolate, it's totally worth it. Then go for it.
Yes, I'm actually running out of those chocolates for myself, so maybe I should also collect it as well and fill out the form to get it. Yeah, that's true. Those chocolates are amazing, and by the way, they are vegan, so it means also if you are lactose intolerant, you can also have it as well. And for those of you that you don't know about the program, so Azure Heroes badges are like a token of appreciation from Microsoft to the dev community. And we have two types of badges, awards and recognition. So for the awards, you can get it by attending different events like this dev show, hackathons, and so on. But for the recognition, you can fill out the form to claim some of our very special badges. And you can also nominate some of your community friends or colleagues there as well. So then it will be the badge from yourself to them. So yeah, go and read more about the program and then nominate yourself or your community friends there. But there are more ways to get some swags, aren't they, Rasmus?
We would like your feedback. Definitely. And this is where you also are able to get a swag box from Sherry. So go in and fill out the form. If you don't fill out the form with your feedback, put it into the chat, put it in Twitter, and make sure that we get it. Also, if you have any topics that you would like to have on the show, then we can find the speaker, or maybe you are even the speaker yourself. Then let us know if you want to speak on Dev Show. We would love to have you on the Dev Show and have you sharing things with the community. So go in, fill out the form, put it anywhere else. It will reach us. It's your show. Just before we move on to the next, so the upcoming event, Sherry, we have a question. So maybe we should just answer that before we are continuing. So it's from Baha. Yes. The beard guy, so you can see on his picture he is also having a beard himself, so maybe that's why he asked the question. I love it. So what is your experience with monitoring functions using application insights? Any alternatives?
I've been using only application insights for monitoring services, not using any other services, but what I do recommend is to use custom metrics. So you add your custom metrics and also custom events to have a bit more control over what you're actually logging, and then also a bit more control over what you're actually on monitoring and alerting on. Because otherwise, you can gather quite a lot by default already. the application insights integration. But I think it's nice if you put some more kind of a business-like event logging in there, and also some bit more business-like metrics in there. So I definitely recommend you to look into the custom metrics and custom events in application insights.
Great, thanks for that. And Sherry, feel free to move on.
Yeah, and you still have time to put your question down there to see.
Yeah, definitely. We will monitor that.
We ask them. So yes, and then the upcoming events. So what is happening in the community for next few days? So tomorrow on Dev Show, we are going to join forces with Azure Community Aalborg in Denmark. And then there will be 2 topics to discuss: Azure Static Web Apps, and then the new container apps that we have there. So tune in there, and I happen to be both host and a speaker on one of the topics. So you will have me again there. So it's on their own meetup. So just go to the 4devs community and then find the link to the event. And then the AI42 community, we have amazing Leila is going to be the running a workshop on the 1st of December. So it is on AI42 on Meetup. So join there and then attend it. I highly recommend Leila. She's an amazing instructor. And then for those of you that you are more towards the front end, we have Manfred Steyer is going to talk about the macro front end with the module federation, which in my opinion goes very much hand in hand with the kind of the topic that we had today. So if we take care of the front end and then we take care of the architectures of our API, we can have amazing Jamstack out there. So yes, on the 9th of December, join this event as well. So all of these events that I listed here are going to be online. So feel free to join. And I would say that is all for today.
See you next year. Not in 1 year, but
I'm up for November next year, right?
November next year, we will have the next session of the show with Marc again, and nothing. To be honest, I didn't have any date to put on there, so I was sure it's not going to be this year. That's why I say next year.
That's amazing. Thanks everybody for tuning in to Dev Show, and thanks a lot, Marc, for being back. It was a pleasure to have you here and to pick on your brain on this amazing topic.
Thanks, it was great. Thanks for having me.
Yeah, amazing. Thank you very much, and see you all later.
Bye-bye.
Bye-bye.